Our aim is to have a traffic engineering over the core network. We got core, the service provider core is in between router 3 to router 7. And this provider has got two customers, A and B. A is R1 and R8. Customer B is R2 and R9. And these two customers are connected to same provider edge. You see, router 3 is connected to both customer A and B in the left. We call this provider edge 1, and we got router 7 connected to two customers A and B. We call this provider edge 2. See, as usual, you should have IBGP. For IBGP, definitely you need to run an IGP protocol. I am going to run OSPF. So with the help of OSPF, you have reachability between this 3333 and 7777, using which you are going to have MPPGP tunnel. MPPGP tunnel. MPPGP tunnel between R3 and R7. We are going to have MPPGP tunnel between R3 and R7. R3 and R7. So this is all possible because you have OSPF reachability. Now we will have two customers with VRF A and VRF B. So this interface is going to be the member of VRF A, and this is going to be a member of VRF B. Likewise, VRF A and VRF B. We'll have some subnets on the customer A to advertise. Likewise here to advertise. Likewise on customer B. And we are going to run OSPF between the customer and the provider. The reason why I use OSPF is most of the customer in the real world use OSPF. It is easy to run BGP and have eBGP. It is very easy. There is no redistribution because between iBGP and eBGP and vice versa, the redistribution happens automatically. So I'm not going to use BGP, rather I'll use OSPF, which is comparatively complicated. So we'll have OSPF between the customer and the provider in all 4 sites. We have 4 sites and 2 customers. And now this is the preferred path. For customer A, the path is via this direction. Even though the path has got more cost, you see, this is 2 meg, 2 meg, 2 meg. Here it is only 2 meg and 2 meg, only 2 hops. Here 2 meg, 3 hops. So by default, the tunnels are only established via router 6. But our aim is to balance the load between these 2 routes. The load need to be balanced. So for customer A, I'm going to take this path. So whenever customer A traffic comes, it will take this path. Though it is a long path, it will go via that path. And for customer B, I go via this blue path. So red is A, blue is B. Going via blue is very normal. Going via blue is normal because less number of hops and the cost is also going to be less. But going via red is not normal. So we are going to have an explicit tunnel as an option, explicit tunnel. On R3 and R7, we are going to configure this traffic engineering tunnel in such a way that VRF of customer A traffic, VRF customer A traffic should pass through the red path. I have mentioned what is red path, R3, R4, R5, R7. And VRF customer B should pass through the blue path, R3, R6, and R7. As I said earlier, first we need to configure this basic topology. Secondly, between the C and PE, we are going to have OSPF routing protocol. OSPF routing protocol. All right. After which we'll get into that VRF traffic engineering per VRF. Yeah. So first of all, let's build this topology. A pasted step-by-step configuration of all routers that you see in the topology. All right. So MPLS traffic engineering per VRF configurations are shown here. It is 22-page document. I'll send it to you by the end of this class. Let us first of all go and build this topology. Put OSPF inside the core, and we'll have an VPN, BGP. Secondly, we'll go to all the customer, put the IP address, run OSPF, and form adjacency with the VRF of the provider edge. So there are two OSPF in three OSPF in R3. In router 3 and router 7, how many OSPF? 3 OSPF. One for inside, which is default OSPF in the default routing table. The other OSPF is for the VRF customer A. The third OSPF is for VRF customer B. All right. So let us now begin the basic. We got the core, and we have the expected path to be taken for customer A and B. And customer A router is now going to be configured. Let's configure it. Customer A will have some subnets to advertise. I'll put them in loopback interface. Interface loopback 1. IP address is 10.1.1.1, 255 or 255 or 255 or 252. Delete 255 you can put. I'm saying, I have 3 addresses in this subnet. Usable address. Next, interface loopback 2. IP address is 10.2.1.1, 255. Just I'm differentiating. This has got some IP address in the subnet, 1, 2, 3, something like that. This has got only one address. And also I'm going to have another loopback to advertise. Is 10.3.101. fully masked. And then interface F00, IP address is 10 dot. I'm going to say 10.250.10.1. 255.255.255.252 here also. I'm going to say 252 because I need just two IP addresses. One on router 1, another one on router 3. So 253 is what I'll configure on router 3 F00. 253. No, 251. Come on, what am I saying? The mask is 252, so one I have given here, two I'll give that. Yes, go.
Yeah, why 3 loopbacks?
See, for testing we need some networks, right? Even if you have one, it is okay.
Okay.
I want to just have some network so that I can see more information in routing table on the other side. If I have only one network, you need to search for that one line of route. If I have three, it is easy to see. There is no other reason. Okay, fine. Now we have the IP address ready. Now let's put OSPF. Router OSPF 1, network 10.1.1.1. Area 0. Network 10.2.1.1.
It will be 10.1.1.1, 0.0.0.3, right?
It's okay. That need not to be exactly matched. Whatever I have in this interface, I'm matching. Area 0. This is the IP address I have in the interface. So I'm matching. If what are the meaning of this? It means that if you find an address 10.1.1.1 on any of the interface, run OSPF. But if I put 10.0. Sorry, if I put 0.0.0.3, it means that if you find 1.2 or 1.3, then you run. I don't have such interfaces.
Okay.
Next is 3. All right, so we have configured customer A with the OSPF. Okay, I think one more physical interface. The physical interface. The physical interface has got 10.250.10.0. This I will say 3 here because it's a physical interface. Next, even if I put here the actual IP address instead of 0, if I put 1 here, it's okay. I can put 0 then here. All right, because we were talking about 3, I'm doing this because you asked me question. Next, R1 is ready. Let's verify R1. Show IP OSPF interface brief. All right, so OSPF is running on all these interfaces. Now let us move on to R2. On router 2, same like what we did in R1, I have loopback 1 IP address. Instead of 10, I'm going to say 20.1.1.1. So instead of 10, on router 1, I put 10. For router 2, I'm putting 20. It will be easy for us to understand from where the route is coming. It's from router 2, so 20. 20 again, I'm saying 255, 255, 255, 255. I'm masking it fully, no need of 252. And then interface loopback 2. It's going to be 20.2. And loopback 3, 20.3. And on the physical interface F0 1/0. Is it 0? Yeah, sorry, 0/0. IP address is 10.250.20.1. See, that's the difference. I'm putting 20 in the third octet. In router 1, I put 10. In router 1, I have put 10 here. So 10.250 means it is CPE link. CPE link. 255.255.255.252. All right, so like before, we are going to say router OSPF1 network 10.250.20.0 0.0.0.3 area 0. Network 20.1.1.1 done. So the routing protocol configuration is also over. 1, 2, 3 to the physical. Yes, it's over. Let us finish router 3 now. Router 3 is an ISP. I'll do one thing. I'll finish 8 and 9, then we'll come to 3. We'll come to code. Let us finish 8 and 9. 8 and 9. Route rate. So I'm going to use Notepad so that I can finish it a bit earlier, faster. Interface loopback 1 IP address is 80 because it's route 8. Remember, for router 1 I give 10. Interface loopback 2 IP address 80.2.1.1. Interface loopback 3 80.3.1.1.1. Interface F0/0. And this is the one which is facing the provider, and we give 250 on the physical interface. So I'm going to say IP address is 10.250.80.1.
No shut.
Yeah, no shutdown. and then router OSPF 1 network 10.250.80.0 area 0 network area 0.
0.0.0.0, sir.
Thank you. You're right. 80.2 and 80.3. This is on router 8. And now router 9 has got 90 instead of 80.
Happy big day, Daddy. Can you buy a cake at the night?
90, 90. And on F00, it's going to be 90 here. 90 here. That's all. So we are going to put this on router 9. It's done. Okay. So we got router 1, 2, 8, and 9 configured over. Yeah. So these things are over. Now I'm going to start with the core. In the core, we are going to have only one loopback for forming IBGP between R3 and R7 initially. Later, we'll be adding more loopbacks, which will be used by the service provider, sorry, customer as a next hop. Okay, so when we go there, I'll tell you what I mean. So as of now, let's focus only on this basic configuration. Yeah. So let's begin router 3. Right. So on router 3, Right, let me see the top. So for default OSPF, this is going to be the router ID. And default OSPF will be running on this loopback as well as on these two physical interface. Let's do the configuration now. R3. Interface loopback 10, IP address is 3333.255. And then interface serial 6/0. I want this interface to be encapsulated with PPP, not the HTTP. See, there's reason. Okay, forget about PPP and all. Let's put IP address. I did not say enter for PPP, okay? Doesn't matter HTLC or PPP. The reason why I was trying to put PPP is in the real world, that is what they do. The real world, they don't want any proprietary protocols, only the standard protocols. So wherever serial link is, you will see encapsulation PPP command. Cisco routers by default will have encapsulation of HTLC. Anyway, I'm not disturbing that because all the routers are here Cisco, so they all support HTLC. So I'm not going to confuse with, I'm not going to put PPP. IP address is 15 dot, as we already discussed, it's going to be 1.1.1, 255.255.252. All right, and what else? Interface serial, the other serial interface is 6/1. IP address is 15.3.1.1.
Previous one no shut is not there.
Okay. Interface serial 6/0. No shit. All right. So let me verify show IP interface brief, serial interface, and then the loopback. Next is I'm going to run the basic OSPF, the OSPF for the core. Router OSPF, I'm going to say 10. And I'll say router ID will be 3.3.3.3 to avoid confusion because we're going to have 3 OSPF. 2 more OSPF for 2 VRFs. So next important thing that I'm going to do is I'm going to say no auto cost. You know why? Because I want to set the bandwidth manually. Yesterday, traffic engineering was telling one path, but when I trace route, it was showing another path. The reason is the auto cost. So I'm going to cancel this auto cost feature. No auto cost. So I said, I'll give you the cost. You don't decide on the cost. That is what this means. I'll give the cost. You don't decide on the cost. All right. And then I need to advertise those networks. Network, one is that loopback interface network. Area 0. Network 15.1.1.1. Area 0. Network 15.3.1.1. area 0. Some operating system will not accept command like this. If you put some number and put 3 here, you should put 0. That's the right way of configuring. Now, I think basic is done. Let's verify. Show IP OSPF interface brief. It should be running on this 3 interface, correct? And slash.
So, you were telling something on right way. Could you come again on that?
Now, see, when you're planning to put some numbers here, you should put the exact subnet from 0th subnet from 0, 1, 2 address. 1 and 2 will be the host, 0 will be the network. Put the network here. That's a good way of doing. Network of this is what? 0. First IP will be 1, second IP will be 2, the broadcast will be 3. So it is good to put that 0, the network portion. Now, what is next? See the cost. The cost on the interface is too much. So we need to set the cost to 2 meg, right? So let me go to the interface serial 6/0, 6/1 and 6/0. On both the interfaces, I'm going to set cost, or I'll say bandwidth, and I'm not going to say cost. I'm going to say bandwidth. I already said no auto cost. Let's see what happens. I'm going to set bandwidth. Because based on the bandwidth, only RSVP decides. Based on bandwidth. So I cancel that auto cost. I'm saying the bandwidth on this link is 2 meg. Likewise, I'll do it on 6/0. Done. Let us now verify show IP OSPF interface brief. I changed the cost. Sorry, I changed the bandwidth. Forget about the cost. Don't worry about the cost. We are not focusing on auto cost. I cancelled the auto cost. Let me show you that show run section router OSPF. So we have said no auto cost. So this is not a problem for us. Right, and also I have assigned bandwidth manually. Show run interface serial 6/0. You will see that 2 meg. So this is matching this picture. We have finished R3. Similar to R3 is what R7 configuration. So I'm going to do some cut and paste. Show run. I'm going to do some cut and paste. What is the loopback? Loopback will be according to the diagram. It's 7777. So I'll go to a notepad and I'll say 7777. And then serial interfaces. 2 serial interfaces. And if you see, we are connecting to router 5 via 6/0. So I'll put 5 here. and 6 here. Right, so next is OSPF. OSPF is going to be 7.7.7.7. This is going to be 6 and 5, no?
So the last one is 15.6.
Yeah, 15.6 is here.
Below.
15.5. We have two interfaces, no?
Okay.
All right, so router 7. It's not on. All right, so we got router 7 also ready. Now let me finish router 6. Hold on a minute, please. On router 3, to form VPN, I need IBGP between R3 and R7. Let us do that also. That also comes under basic. So router BGP 6500 or 65,000. And then I'm going to say I got a neighbor called 7.7.7.7, which we just configured, router 7. That also in same AS 65,000. And then whenever you speak to the neighbor, use the update source loopback 0. Sorry, loopback 10. Alright, so similar configuration is what going to go on router 7. Router 7, router BGP 65,000. Neighbor is 3.3.3.3. Remote AS is same number, BGP. Neighbor 3.3.3.3. Update source is loopback 10. So BGP is also good. Even you can also do activation of VPN v4 now itself. Address family, VPN v4. Neighbor is 7.7.7.7. Sorry, 3.3.3.3. Activate. Likewise on R3, address family VPN v4, neighbor 7.7.7.7, activate. Right. Rest of the things will be later on R3 and R7. Now, R3 is over, and R7 is also over with the basic things: OSPF, IBGP, and VPN v4. In R3 and R4, all the customer-related configurations are in R3 and R7. Customer-related configurations are pending, like VRF, assigning IP address to the customer-facing interface, assigning the interface to the VRF, and etc. We'll do that later. That all comes with the MPLS traffic engineering package. Now on R4, okay, let me use the notepad. On R4, I'm going to have a loopback 10. I'm going to have loopback 10 with 4.4.4.4. This is R4. And R4 serial 6/0 is going to have 15.1. Earlier we said 1. On the other side we have given 1, and here we should give 2. Yeah, so things are looking good. Bandwidth command same 2K. And on 6/1, it's going to be 15.2. Because it's facing the provider or 2. See, I told you this is provider 2. This is facing provider 1, so we gave 1 here. This is facing provider 3, so we gave 3 here. Here it is facing provider 2. I should have given. I think I have to change the IP address here. We'll come back and see this changes later. Now, this is still correct. And this is 2, and this is the first interface, the second interface, so dot 1 and dot 2. So dot 1 is correct here. Dot 1 is correct. Okay, so serial interface with IP address and bandwidth is already given. Now the OSPF. The OSPF is 2.2.2.2, sorry, 4.4.4.4. This is router 4, no? So 4.4.4.4. And the networks that need to be advertised are area 0 and 15.1 and 15.2. That's all. There is nothing more on router 4. Show IP OSPF interface brief, and I should see OSPF. Okay. Show IP interface brief. I think I did not say no shutdown. Interface serial 6/0 no shut. Interface serial 6/1 no shut. This may be the same condition on router 7. That is okay. We'll check router 7 later. So now we are moving on to router 5 configuration. Router 5 is P2, provider 2. Router 5 will have 5.5.5.5 on the loopback. And the serial will be 5. This is 5 now. This is here, so 5.2. I gave 5.2 earlier, so 5.2.1.2. This is right. This is right. And now the other interface is what the matter. The other interface is I need to check what I have given in 6/0 on 7, router 7. Router 7 show IP interface brief. What did I give? Okay, this is okay. This is okay. 15.5 is okay. So 15.5.0.0, I'm going to make just 2 here. So that there will be some uniform.
No shit.
No shit. So on router 5, that is not bad. We are going to say 15.5 1.1. Okay, so the router ID is going to be 55555. And then
Network.
5.2 is okay, the same. 5.5 will come here. They all belong to area 0. Alright, so that's all here. This is on router 5. Alright, so router 5 is also over, router 7 is also over partially, router 6 and router 6 is what left. Router 6 is what left. Now by now I should see a BGP session between R3 and R7. Look at this, I see OSPF. Show IP BGP summary. Ping 7.7.7.7 with the source 3333. Okay, no problem. There is some issue somewhere. Show IP OSPF neighbor. There is no neighbor on router 5. Show IP OSPF interface brief. Show IP interface brief. Interface are down, that's why. Serial 6/0 no shut. Interface serial 6/1 no shut. So now let's move on to router 3 and check whether we are able to ping. Router 3. When this ping comes, BGP will also come. Router 7, Do you have a neighbor? Yes, it says I have a neighbor. BGP has come. So now go back to router 3 and you will definitely ping this. Okay, so one path is ready. Now we need to bring router 6 to make the other path ready. Router 6 configuration, again, let's go back to the notepad and make it simple. 6.6.6.6 and serial 3/0, it's 15.3. 15.3. And yes, it should be 2, correct. And then 6/1 will be 4. Yeah, I want to keep it 4 here because I used 5 here. I'll keep it 4 here, so I need to do some changes on PE2. PE2. Router 7. Show IP interface brief. Okay, this 6 I'm going to change it into 4. (15.4.1.2). Which means I
Then
need to
the
change the
OSP.
OSPF. Correct. Show run.
Happy birthday, Dad.
Here it will be 4. Okay. Show IP OSPF interface brief. Alright. Show IP interface brief. Is it up or down? The interface is up, but the other side is not configured. The line protocols are down. Now let us do it for router 6. Router 6, as we said, this is going to be 1 year. This is going to be 3 year. 3.2, and this is 6.6.6.6 router ID. And this is going to be 3 and 4. All right, after I paste on router 6, where is router 6? So what I'm trying to verify is after I paste from R3, if I trace route to 7.7.7.7, right now it is going via this guy, P1, which is 1, P2, and 5. Means it's going via the upper path. But after I paste this, and I need to bring the interfaces up. Interface serial 6/0. Oh shit. Serial 6/1. Oh shit. After this, I should see OSPF neighbor here. And then when I trace it from R3, it should be 2 hop. Okay, one neighbor has come. Another neighbor I'm expecting with R3. Okay, it has come. Now if I trace it earlier, it was 3 hop. By this time, say earlier it was 3 hop, but this time it should be 2 hop. Correct. So which means our both the paths are up and our platform is ready. The platform is ready for the MPLS traffic engineering. Now let us go and check on R3 whether we got VPN. Show BGP, VPN, V4, unicast, all summary. Yes, we do have a VPN ready. Now what is left is the VRFs, and the routes from the customer should be learned on the VRF table and need to be redistributed into BGP. That's the first step. But for that also you need MPLS. Remember, MPLS is also the basic MPLS, the core we need to enable. So this all comes under basic. MPLS, VRF, and bringing the customer route and giving the customer route into the BGP by redistribution. After which, we'll be configuring tunnel, and we will say which tunnel will use which path and which tunnel will be given to which customer. When you finish this lab, you will understand how it happens in the real world, ISP, how the service provider, the core service provider, works in the real world. Now we have 2 customers, they may have 1,000 customers. The logic is going to be the same. All right. So let us now move to the next one. Next verification. I'm not going to get into VRF today, it will be too much. We have built the topology. I recommend you also to do these things what I have done up to now. I'm going to share a document with you which has got complete configuration, all VRF, all customer, all everything. But as of now, I just finished only 40% of what you will see in the document. I'm going step by step. In the document, it won't be step by step. It will be mixed. I have only the running configurations pasted on the document. So I'm going here step by step for you in the class. Try to follow these steps. IP address schemes, it need not to have the same scheme which I'm having. I try to match with the document which I already have it for sharing with you. That's why I took some time matching the IP address which is there in the document. If you want to follow the same, you can do the same.